So in the first part of our section 1 notes, we talked about how the difference quotient from chapter 2 is really just our definition of a derivative now, our limit definition of a derivative. The middle part of our section 1 notes are going to give you an alternative to the difference quotient. Still basically means the same thing, just a different way to set it up. First thing we're going to do is prove it, and then the second thing is use it as example C in our notes. So the alternative definition is now our derivative equals the limit as x approaches c of f of x minus f of c divided by x minus c. Now what the heck does that mean? Well, first of all, you need to understand that we're finding the derivative of a function at c, or an x value of c. So we're trying to, in the end, find the slope of the tangent line through that point. There we go. Sorry for the awkward silence. I couldn't get that line to erase. Okay, so we've talked about how the only way we can find the slope of a line is if we're using 2 points, and a tangent line just is based on 1 point. So what we're going to do is pick another value somewhere out here. We're just going to call it x. And so that will line up right about there. And we're going to find the slope of the secant line that will connect those two. Okay, so to find the slope of that line, we need to find y values, and so the y value here would be f of x, the y value here would be f of c, whatever we get when we plug in those certain x values. So the top part of our slope formula, the y minus y, would be f of x minus f of c, and we're going to divide by the difference of the x values. So in this case, in our picture, we're going to take our x value minus the cx value. So we get x minus c there. Okay, so keep in mind that's the slope of the blue line. We want to have the slope of the tangent line at point C. And so what we're going to do is move point x, the x value here, closer to C. That's going to make this point move closer and closer this way. And if you can visualize that, eventually that blue line is going to turn more into a tangent line rather than a secant line, because these points get so close together. And so how do we express that? Well, we put in front of this fraction here, we say the limit as x approaches c, and lo and behold, we have the definition they had up there. Now, to me, this seems like an easier way to define it. You'll find that if you were to use this all the time, the algebra, as far as simplifying things, gets really complicated, but it is good just to be able to recognize it. We're going to go through one example of this in the next slide. Okay, it's actually the same exact one we did with example A. We're just going to use the different notation. So we'd start off by saying that f prime of x is going to equal, now it's the limit as x approaches c of, on the top, f of x, so 3x plus 2 minus f of c, and so that means put a c wherever you see x's, so 3c plus 2, and notice I'm using the brackets again. Helps keep things straight, and on the bottom it's going to be x minus c. And so what we want to do eventually is plug a c, as x approaches c, we're going to plug a c in for all the x values. We can't do that down here because we'd end up with a 0, so I need to figure out a way to get rid of this, and that's where the algebra can get a little complicated sometimes. What I can do, though, or what I do notice, is that if I were to simplify this, here we'd have a plus 2, here we would end up with a minus 2 because we have to distribute the negative symbol. So that's going to simplify things a little bit. I'm left with the limit as x approaches c of 3x minus 3c over x minus c. Still can't just plug a c in for the x's. I still have that denominator to worry about, but I can, if I'm thinking through this, I can do a little factoring. So I can factor a 3 out of both parts on the top, so I have a x and a c left behind. Still an x minus c on the bottom. You think of that as being in parentheses. And now, because everything is 3 chunks multiplied or divided together, these things will cancel off. If I had x's left over now, I could go ahead and plug a c in for them because I've gotten rid of that nasty denominator part. But I'm just left with a number in this case, the number 3, which is the same answer I got in part A, so that worked out fantastic. Let's see, what are we looking at in the last part of our notes here? We're going to make some connections between different graphs of the original function and derivative, so there is a third section, or a third video for this section.